Hi again. This is the last part of the models in Excel. It's for the reliability model. Okay. So again, same as before, we have the data of the problem here. So as you see here, for the delay, it could be 5, 10, or 15 minutes. So we have the probabilities. We have the cumulative function or CDF. And for the bearing life, we have the data here, the probability, and the CDF. Okay, so here we have two policy, current policy and proposed policy. In the current policy, anytime that a bearing fails, the system calls the mechanic, and the mechanic will come after a delay time to the system and will replace the bearing. Okay, and so here we are going to simulate the system for 15 changes, for 15 replacements. Okay, so here we have the changes J from 1 to 15, as you see here. And for the life of each bearing, so here we have three columns, right? Bearing 1, bearing 2, and bearing, this should be 3, bearing 3. Let me modify this here. So bearing 3. So we have three columns for three bearings. And at first we generate a random variable from the distribution that we have for the bearing life for the life of this bearing. Okay, so we do this by the discrete empirical function. And as you see here, for bearing 1, it's 1,000 hours. For bearing 2, it's 1,400 hours, and for bearing 3 is 1,300 hours. Okay, so here we assume that after 1,000 hours of the bearing 1, it will fail. And in that time, we call the mechanic, and the mechanic will take 5 minutes to be in place. So that's the delay time. And then it takes 20 minutes to replace this bearing, because by the assumption of the problem, the change time for one bearing is 20 minutes. Okay, so yeah, here we have generated the random variables for the life and delay time by having the distributions, and we have the data for 15 changes of each bearing, right? That's the current policy. But in the proposed policy, we are having this policy that anytime that a bearing fails, in that time when mechanic arrives at the system, the mechanic will replace all the three bearings. Even the other two are actually working, but the mechanic will replace all the three ones. Okay, so this is the proposed policy, and we are going to see how it works in comparison with the current policy. Okay, so again, here we have the 15 changes, 1 to 15, and here we have the three. At first we generate a random variable for the life of the three bearings, right? So here we have 1,600 for the bearing 1, 1,100 for the bearing 2, and 1,200 for the bearing 3. So the minimum of these three will obtain the first fail among the three bearings, right? So which is 1,100. So at time 1,100, bearing 2 will fail. So in that time, the mechanic comes and will replace all the three bearings. So this is why we have the failure time, and we have the delay in order to replace all the three bearings, right? So this is why we have just one delay time for each set of replacement. But in the current policy, we have actually one delay time for replacing each bearing. So for each row of change, bearing chains, we have three delay times. Okay, so now we need to actually calculate the performance measures here. So the cost of bearing in the both systems, we are going to replace 45 bearings, right? Yeah, that's the same. So 45 times 32, the cost of each bearing will be the same between current and proposed policy, right? The cost of delay, as you see here, if you sum up the J26, L26, and N26, which are these numbers, J26 the total delay time for bearing 1, L26 and N26. So if we add up these numbers, it will be the total delay time, right? And if we multiply this by 10, which is $10 as the cost per minute for the downtime of the machine, so it will be $3,100 for the current system. I mean, for the cost of delay. But here, since we have just one column for the delay time, so we consider U26, and if you multiply this by 10, it will be $950 for the proposed system. Okay, and the cost of downtime for the repair, that was the previous one was for the delay of the mechanic, but for the repair, again, each repair, I mean each change of one bearing takes 20 minutes, two bearings takes 30 minutes, and three bearings takes 40 minutes, right? So here for the current we have 45 change, so we need to multiply this by 20, will be the total minutes of change, and again times 10. That will be the cost of downtime for the repair or replacement of the bearings. But for the purpose, we have 15 replacement, and each time we are replacing all the three bearings. So the time is 40 minutes. So 15 times 40 times 10 will be the cost of downtime for the machine, for the repair of the machines in the proposed system. Okay, and the cost of mechanic, again here we have 45 times 20 and times $30 per hour. Then we divide this by 60 because 20 is in minute. So this will be the cost of mechanic for repair. And again here we have it for the proposed system the same manner. And the total cost will be sum of all these costs. Okay, so as you see here, for the current it's $13,990, but for the proposed is $8,690. Okay, and so as you see here, the life of 45 bearings is in current system is usually greater than the proposed system, and it makes sense because in the proposed system, at any failure, we replace the other two bearings which are still working, right? So because of that, the total life of 45 bearings will be less in proposed system compared to the current one, the current system. But in order to have a measure to be comparable between these two policies, here we consider the cost per 10,000 bearings hours. Okay, and as you see here, we consider D13, which is the total cost, divided by D15, which is the life of the bearings, and then multiply this by 10,000. Okay, so as you see here, it's $2,297 for the current policy and $1,735 for the proposed system. It's much less than the current system, right? And if we refresh the numbers, anytime you see the cost per 10,000 bearing hours in proposed system is much less than the current one. See? And again, in order to have more reliable results, we need to consider the replications. Here I didn't, but we need to actually to have replications 500 times or 1,000 times. And then by having all those replications and having the average among the replications, we will have more stable results for these measures. And then we can easily wrap up our comparison that which one is actually better. Okay, so and that's it. Okay, thank you.